Welcome, ladies and gentlemen. So what I'd like to do is show you how to evaluate for our 6 trigonometric functions when given an equation and a constraint of where that triangle has to be. Now, we did problems like this before where we just had the equation, we just drew a right triangle, and it really had no reference to the origin or quadrants. But now we're saying, I want you to evaluate the 6 trigonometric equations when this triangle is in quadrant 3, or when this triangle is in quadrant 2. So let's go ahead, and what we're first going to do is go ahead and identify what information we have, and then draw a triangle, and then make sure that we have the triangle in the correct quadrant. So first thing is, you can see here we have a negative. Now, the most important thing whenever you see a negative with a ratio, remember the hypotenuse is never negative, right? So therefore, my adjacent side we know is going to be negative. Now remember, cosine of an angle is the adjacent over the hypotenuse. So I a lot of times just like to write that in there just so I kind of like remember it and I don't really make a mistake. Now, when we're creating a right triangle, there's basically four triangles that we can use. If you remember when we discussed creating right triangles with the reference angle, the angle was always off of, or the angle always came off of the origin, and it was always with the respect of the x-axis. Right? So it looks something like that. And all these right angles here would have been like this. OK, now the main important thing is we know that our hypotenuse is 5. So all of these could represent a hypotenuse of 5. The other thing, though, is that our adjacent side has to be negative. That means the adjacent side, so here's your angle, right? So here's our angle theta. Each one of these, the adjacent side is going to be on the x-axis. Well, that adjacent side has to be -3. So since it has to be -3, there's no way the triangle can be in one of these two, right? Or you could even just look at it and say, all right, well, I know that the angle also has to be in quadrant 3. So it's very common that students will say, oh, cosine is negative, so let me draw the triangle to look like this, right? And they say -3, theta, and they say 5. Well, that's incorrect, though, because that triangle would represent a triangle that's in the second quadrant, right? So you have to be very, very careful. The triangle is going to be represented in the third quadrant, so it's going to look like this. And the reason why that's most important, the reason why I'm trying to determine that is because, well, first of all, when you use your Pythagorean triple or use Pythagorean theorem, we're going to identify this side length as 4. Well, if the triangle looks like this, that's +4. But when it's in the third quadrant, that's -4. So that's why it's so important that the constraint, that we have the constraint, because that tells us now that our y value is going to be negative. OK, so just don't always assume, oh, the triangle, let me just draw it. You've got to make sure you're very, very careful with the constraints that you are using. OK, so now you can see that I have my two side lengths. That's 5. So I have -3, -4, and 5. Well, now I can easily go ahead and devise what is going to be my sine, cosine, and tangent. So sine of theta is going to be opposite over adjacent, so -4 over 5. Cosine of theta, they already gave us, which is -3 over 5. And the tangent of theta is opposite over adjacent, which is -4 over -3, which is +4/3. The other thing, too, is for those of you that are like, how'd you get -4? I'll just go through it. -3 squared is one side length, plus, let's just call it x squared is that side length equals 5 squared. OK, so there's the work. When you go ahead and solve using Pythagorean theorem, you get x equals 4. However, I noticed that that was a Pythagorean triple, so I didn't have to go through it. Now, so we got the first 3. And the next nice thing about this is now we can use our reciprocals to find the cosecant, secant, and cotangent. So we have cosecant of theta equals -5/4. The secant of theta equals -5/3. And the cotangent of theta equals +3 over 4. And there we go, done. All right, so now let's go ahead and look at sine of theta equals 5 over 13. Again, a very common thing that students will do here is they'll say, OK, well, this is easy, Mr. McLogan. I got this. Right? And they say, OK, 5 over 3. Therefore, here's theta, right? Because remember how I wrote on the triangles? I don't remember. OK. Remember we wrote on the triangles? The triangle is going to look like this. It's always in respect where the central, our theta is going to be an angle with the vertex at the center. So it's going to look like that. And you could say, all right, opposite side is 5. And that's 13, right? And you say, hey, good. But we have a problem. Because the constraint is saying we need this to be in the second quadrant, not in the first quadrant. So we say, all right, well, can I rewrite a triangle then with the same ratio, 5/13, but in the second quadrant? And yes, you can. So again, remember, using the same kind of types of triangles that we were talking about, has to be with the vertex on the, or the angle at the origin, has to have the right angle with on the x-axis. And you can see that, yes, hey, guess what? This is different, OK? But the reason why this is so important as far as going to the left now is because now you can see that my x value, so if you use this one, in the first quadrant, the x value would have been positive. Whereas when you use it in the second quadrant, my x value is negative. And again, by using Pythagorean theorem or knowing that this is a Pythagorean triple, I'm able to identify that it's negative 12. And again, I know the answer is 12, but it's negative because it's in the second quadrant. And that's why, that's how the constraints come in so important. If you didn't know how I got 12, then 5 squared is 25 plus x squared equals 169 minus 25 minus 25. X squared equals 144. Square root, x equals 12. Well, we know x equals 12, but remember, constraint is second power, or second quadrant, so therefore it's negative. Well, now that we know the last side, now we can evaluate for sine, cosine, tangent. So sine of theta equals opposite over hypotenuse, 5/13. Cosine of theta is adjacent over hypotenuse, negative 12/13. Oh, they already gave us those. Tangent of theta is opposite over adjacent, 5/-12. I guess I should have identified the opposite and the adjacents, right? Remember, here, that's always your hypotenuse. We already identified that as your adjacent, so therefore that's your opposite. Should have done that. Here, remember, sine is opposite over hypotenuse. So we know that's the opposite. We know that's the hypotenuse, so therefore that has to be the adjacent. I kind of started doing everything really, really quickly, so I want to make sure we go back to there. So therefore, that's how we got all of those. Remember, just make sure you know those ratios. Now let's go ahead and do the reciprocals. So we have the cosecant of theta equals 13/5. The secant of theta equals, why is 1 negative? OK, is going to be negative 13/12. And the tangent, OK, or the cotangent of theta equals negative 12/5. And there you go, ladies and gentlemen. That is how you evaluate your 6 trigonometric functions when given your constraints, when given an equation of a function as well as a constraint. Thanks.